In today's lesson, we're going to learn about slope-intercept form. We learned about slope last class, so this class we're going to learn about x and y intercepts before we combine it together for slope-intercept form. An x-intercept is going to be the x value at which the graph crosses or intercepts the x-axis. It will always be in the form of x comma 0 written as a point. For the y-intercept, it's going to be the y value at which the graph crosses intercepts the y-axis. It will be in the form of 0 comma y written as a point again. To find the x-intercept given a graph, we want to find where the line crosses the x-axis. After we find that, we answer in the form of x comma 0 just like we had over here when we talked about x-intercepts. For the y-intercepts, we want to find where the line crosses the y-axis, and then we'll write that as a point, 0 comma y. Let's go ahead and look at our first example. I'm going to go ahead and put my x-intercept in pink when it crosses the x-axis. It might be great to start by labeling these axes with your x and your y. There's the point where it crosses the x-axis, and that is at a value of -2. I go ahead and name that point -2 comma 0. I fill in what my x value is, and I always have 0 for the y. For the y-intercept, my x is always 0, and I'm looking at the y-axis. So I'm going to put a purple point where my line crosses the y-axis. That is at -6, and then we just name it as a point, 0, -6. The x value is 0, and the y value I input into the y value position in my coordinate. Let's go ahead and try this next one. And pink is going to be my x-intercept. Remember, this is the x-axis. And our purple is going to be my y-intercept. Remember that the vertical axis is your y-axis. From here, we go ahead and name the values. The x value of that pink dot is at -4, comma 0 to write it as a point. And then the y-intercept is going to be at a +2, 0, comma 2, writing it as a point. Let's go ahead and look at x and y intercepts in a table. When given a table, I ask myself for the x-intercept what the x is when y equals 0. That's going to be written again in the form x comma 0. Then it's the opposite for the y. I ask what is the y value when x is 0. Then I write it in the form 0 comma y. Let's go ahead and look at our table. So I'm asking that first question for the x-intercept. I'll highlight it in pink. When my x value 0 is at this point, so I'm answering with the x value that corresponds with it. I can write it right as a point from my table. That would be 2 comma 0. Remember, you always name points as x comma y. Pulling it right from my table, the x and y value of that row in the table. Then let's go ahead and highlight the y-intercept in purple. That's where x equals 0, and I highlight the same corresponding number in that row. 0 comma -4 is what I'm pulling from the table as my x and y point for the y-intercept. For example number 4, let's go ahead and highlight when we have y equal to 0, and we'll name the x value with it. 6 comma 0 is my x-intercept. It's kind of backwards because you have the x value and the y value 0. Then for the y-intercept, again, you're looking for the x value being 0 and answering with the y value. So again, you're opposite when looking at the zeros, but answering with the x and y values. Now that we know intercepts, let's use it for our slope-intercept form. Now we combine the two together for slope-intercept form. That is y equals mx plus b. We have our m representing always the slope, and I like to put a reminder that it's always going to be the number multiplied to x. And then for the b in slope-intercept format, it is going to be taking the sign with the b to represent the y-intercept. That's going to be your starting point on the y-axis, just like we talked about for a y-intercept meaning. Let's go ahead and look at example 1. Example 1, we have y equals -3/4 plus 1. Right away, I'm going to pull what my slope is and what my y-intercept is. That's my first step, identifying the two. Well, my slope is -3/4, and then my y-intercept is a +1. The second step to graph this is plotting that y-intercept. So on my y-axis, I plot a point at +1. From here, I'm going to use the slope to show rise over run to determine the additional points along the given line. Now for -3/4, I can go down because a -3 means down 3, and then I can run to the right 4. That's one option here given -3/4. I also can go ahead and put the negative in the denominator. Make it 3/-4. +3 in the numerator means up 3, and a -4 in the denominator means left 4. I can do both of those to get a complete line across the whole graph possible. So from that purple point, I go down 3 to the right 4. Then I keep doing that pattern down 3 to the right 4 until I can't go any longer. Now I want to go in the opposite direction to make sure that I get the rest of my line. I can go up 3 from that purple point and left 4, up 3 and left 4 to make this perfectly straight line. I use a ruler to connect it all the way through, giving me my final graphed line answer. Let's go ahead and try another one. For this example, be careful because I have to go ahead and highlight the slope in blue that's multiplied to my x. And then my y-intercept is the variable list term. So there's no variable to it. If you need some help here, we can rewrite this so that is in slope-intercept format. I can put y equals still, but I can move the x term in front and have the -3 subtracted after as my b. That way it comes out more clearly that my b is -3, and my x that is multiplied with the division of 2 goes with my slope here. Now, x over 2 is really 1x/2. So I want to take the coefficients, aka the numbers in front of x, as my slope. And I can kind of separate it a bit more to show you that the slope is 1/2. Now I have two options for that 1/2 slope to be plotted on my graph here. 1/2 means up 1 since it's a +1, and right 2 since it's a +2 in the denominator. Or a 1/2 slope can also be the opposite of that, which is down 1 and left 2. I can do the exact opposite of what I just did to keep my line completely straight. Let's start at a -3 for the y-intercept, and let's apply the slopes. From that purple point, I go up 1, right 2, up 1, right 2, until I can't go any further on my coordinate plane. And then now, to get the points on the left side of that purple point, I go down 1 and left 2 to keep the slope the exact same along the way across the whole graph I am given. I connect all those points with a ruler and a straight line to have this full graphed line. Let's go ahead and try the next example. My next example 3 is y equals -2x. Well, I can tell you right away that the number in front of my x is my slope, so I got -2 as my slope. The y-intercept is always added or subtracted after the x. If there's nothing there, it's going to be 0. So that's my y-intercept. Well, y-intercept of 0 is just at the origin there. Then I have to apply a slope of -2 to this purple point. Let's go ahead and talk about what -2 slopes looks like. Well, right away, I need it to be a fraction, so I can always put a whole number over 1, always, always, always. This way I can get the directions of down 2 and right 1, or I can put the negative in the denominator and make it an up 2, left 1. Going the opposite of what I just did. So I'll apply the first slope down to right 1 until I can't go any further on my graph. To get the rest of my line from that purple point, I go in the exact opposite direction. Up because that's the opposite of down, and left because that's the opposite of right. I must do the exact opposite of both the numerator and the denominator. I go ahead and graph this line, getting my final answer. Let's go ahead and try talking about slopes. So we're just talking about slopes, and for a sketch, a positive slope is always going to be one that rises from left to right. Just like how we read left to right, this one is rising from left to right. A negative slope is going to be when I am decreasing, falling, going down from left to right. So again, just like I read, it's now falling, going down, decreasing from left to right. An undefined slope is always, always, always going to be a vertical line. Let me draw a little bit better vertical line here. I'll use a tool to help me out here because you want that vertical line perfectly up and down. Put arrows on both ends showing it goes on forever. And that is always a vertical line having an undefined slope. For a zero slope, that's going to be one that is horizontal. So again, I'll use a tool to make it a nice straight horizontal line here. Putting in arrows on both ends to show it's going to go on forever, having a horizontal slope. To help us remember here, for undefined, I can count from point to point. If I count from point to point here, I'm counting rise over run as a reminder from last lesson. And that's going to be rising 1, but running none. I don't go anything left to right. I just go up 1 to get from one point to the other and over 0. When I divide that in the calculator, I get errored, which is meaning undefined. Then, for instance, for my horizontal line, I count from one point to the other. I rise up 0, but then I do run 1 to the right. 0 divided by 1 when you do that on a calculator comes out to be 0. Last but not least, we have kind of our special cases for graphing lines. I want to graph y equals -6. Well, right away, I'm thinking about this in slope-intercept format. Y equals, I'm missing my x term, so I have 0x. And then after that, I'm subtracting 6. So my b, which is my y-intercept, is going to be -6 for this problem. My slope, because there's no x, is going to be 0. So what I do is I plot points here that are at -6. So I go down to -6 and I do a slope of 0, which is up 0, but I can go over every time my y value is -6 here. I connect all these points with a nice straight line to give me my final answer. To help me to remember how to graph this line, I like to recall that I want to look for points where y equals -6. The x value can change, but the y value must always be -6. That's going to kind of help me remember how to graph this one. Looking at example number 2, I have graph x equals 2. I want to point out that this is a very special case because it is not y equals. When it's not y equals, I have an undefined slope because I have no y equals, and I have no y-intercept. Well, what's that going to look like? Let's think back to what we were just talking about here, which is that to graph this line, I want to find points where the x is 2. So right away, I find where x is 2 on my graph, and I plot some points that would have 2 as an x value. I notice that it's making this vertical line here. I could keep going with my points or start drawing my vertically straight line here as the final graph of this equation. For example number 3, I want to graph x equals 0. Right away, I want to make note that this is not in y equal to format. So when it doesn't have y equals, when it x equals, I always have an undefined slope, and my y-intercept again is going to be none. We go ahead and graph this line. I always like to remember to help me graphing that I'm looking for graphing points where x is 0. Well, x is 0 here, 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 and I can keep going with my points. As you see, it's going to be a perfectly vertical line when x is equal to 0. The next example, I want to graph y equaling 0. Again, I want to remind us that this is in the format y equals mx plus b with no x that's going to be 0x, and I have to add the 0 that was already there. The plus 0 tells me what my y-intercept will be, which is at 0. Then we go ahead and talk about the slope, which is going to be 0x here. I have it y equals, so it's not like the last problem, so my slope is 0. Well, from here, I plug that y-intercept of 0 in, and then I'm doing a 0 slope. To help you remember 0 slope, that would be up 0 and to the right any amount. And same thing as well. You can go to the left, up 0, but any amount left to make it a 0 overall. To help you graph this one, I like to recall that I want to plot points where y equals 0. And all the points I plotted meet that criteria. I connect the points, making a straight line going across my whole graph here, my whole coordinate plane, to have my final horizontal line answer.